The last module completed our introduction to the physical layer of the TCP/IP model. We covered the different types of transmission media, guided or unguided, made patch cables, and discussed the various ways that a signal is transmitted across a transmission media, parallel or serial. And when it was serial, we talked about the timing that was used. Now we're ready to begin layer 2 of the network interface layer. We will examine packet switching and network topology. The network interface layer provides connections between hosts on the same network for accessing the physical medium. Communication between hosts uses a physical address, better known as the Media Access Control or MAC address. The PDU is a frame. Devices on layer 2 are switches, wireless access points, and the network interface card or the NIC. Some of the protocols that reside on the network interface layer are Ethernet, ARP, IEEE 802, including the wireless protocols 802.11, asynchronous transfer protocol, and spanning tree protocol that prevent loops from occurring when switches are interconnected. There are basically two ways to direct a communication between communicating parties: circuit switching and packet switching. Let's talk about circuit switching. In circuit switching, communication mechanisms enable or establishes a path between a sender and receiver with guaranteed isolation from paths used by communicating parties. Circuit switching networks use electronic devices to establish circuits. Instead of having each circuit correspond to a physical path, multiple circuits are multiplexed over shared media, and the result is known as a virtual circuit. Circuit switching is usually associated with telephone technology because the telephone system provides a dedicated connection between two telephones. Analog telephones used circuit switching with electromechanical switches. Historically, when you dialed 0, you were connected to an operator who would plug and unplug the proper wires on the board, which literally connected two phones through a single line. Every one of the holes on the board corresponded to a specific telephone line. There are three general properties used to define circuit switching in the paradigm. First, it is point-to-point communication. That means a circuit is formed between exactly two endpoints. Second, separate steps are needed for circuit creation, use, and termination. Circuit switches are established when needed as opposed to permanent circuits. Third, the performance of the communication path must be equivalent to an isolated physical path, so the communication between two parties is not affected in any way by communication among other parties. In other words, circuit switching must provide the illusion of an isolated path for each pair of communicating entities. Switch circuits use a three-step process analogous to placing a phone call. A circuit is established between two parties. The two parties use the circuit to communicate, and finally, the two parties terminate the call. Circuit switching provides the illusion of an isolated physical path between a pair of communicating entities. It creates a path when needed and is discontinued after use. Modern circuit switching networks use electronic devices to establish circuits. Let's talk about packet switching. The main alternative to circuit switching is packet switching, and packet switching forms the basis for the Internet. Note that in packet switching technologies, all users have shared resources. Multiple sources compete for the use of shared media, so a packet switching system uses statistical multiplexing when transporting packets across the network. This figure illustrates the concept. Statistical multiplexing is a multiplexing technique that allows information from a number of channels to be combined for transmission over a single channel. Statistical multiplexing normally implies on-demand service rather than one that pre-allocates resources for each data stream. However, a statistical multiplexing scheme does not control data transmissions. A packet switching system requires a sender to divide each message into blocks of data known as packets. The size of a packet varies, and each packet switching technology defines a maximum packet size. The chief difference between packet switching and other forms of statistical multiplexing arises because a packet switching system requires a sender to divide each message into small blocks of data known as packets. The size of a packet varies. Each packet switching technology defines a maximum packet size. Packets are not large. A common maximum packet size is 1500 bytes. With packet switching, the user does not have to ask if a circuit is available or set up a communication path. The resources are always up. There are three general properties used to define packet switching. 1. Packet switching is an arbitrary, asynchronous communication allowing a sender to communicate with one recipient or multiple recipients. A given recipient can receive messages from one sender or multiple senders. As stated, communication is asynchronous and can occur at any time with arbitrarily no delay between successive communications. Number 2, a sender does not need to perform initialization before communicating since the system is ready to deliver packets to any destination at any time. Thus, no setup requirements. Since the system remains ready to deliver a packet to any destination at any time, the sender does not need to notify the underlying system when communication terminates. Number 3, multiplexing occurs among packets rather than among bits or bytes, and performance varies due to statistical multiplexing among the packets. A major advantage of packet switching is the lower cost that arises from sharing the underlying communication system. With a circuit switch network, the number of independent paths required is equivalent to at least the number of communicating devices divided by 2. In a packet switch network, a connection for each computer is required, but requires only one shared path between the users. Let's do a comparison between circuit switching and packet switching. Public switched telephone network and packet switching. Circuit switching has end-to-end circuits, sequenced communication. Public switched telephone network, PSTN, traditional telephony, not cost efficient. Circuit switching is not cost efficient. It has less delay. It is highly reliable. Failures typically mean the circuit must be rebuilt. On the other hand, packet switching, the packets represent pieces of data. There is an unordered transmission. We usually find this in the internet. Voice over IP. There is a shared cost model, a higher delay, and it is less reliable. It can reroute around failures. The major benefit of packet switching over circuit switching is cost savings. That's why it is the most prevalent. Packet switching technologies are commonly classified according to the distance they span. The table provides a description of the 3 major network classifications. Because packet switching systems rely on sharing the underlying resources, each packet sent across a network must contain the identification of the intended recipient. In order for this to work worldwide, senders must agree on the exact details of how to identify a recipient and where to place the identification in a packet. In other words, standards are required. Standards organizations have accepted the responsibility to create protocol documents that specify all these details, and these protocols have been shaped by various organizations. For instance, since 1980, the Institute for Electrical and Electronic Engineers, the IEEE, is known for the Project 802 LAN MAN standards. The IEEE is made up of committees to produce standards for networking and is mostly composed of engineers who focus on the lower two layers of the TCP/IP reference model. Other standards organizations exist which emphasizes particular layers in the stack. These include the World Wide Web Consortium, W3C, and the Internet Engineering Task Force, IETF. Each standards organization focuses on a particular layer of the protocol stack. The IEEE, the Institute for Electrical and Electronics Engineers, focus on the two lower layers, which would be layer 1 and layer 2. The IETF focuses on layers 3 and 4. The World Wide Web Consortium supervises layer 5. The Institute for Electrical and Electronics Engineers, IEEE, divides layer 2 of the protocol stack into two conceptual sublayers, as this table illustrates. The logical link control, the LLC, is the sublayer which specifies addressing and the use of the addresses for demultiplexing. The media access control sublayer, the MAC layer, specifies how multiple computers share underlying medium. It is a logical division where the LLC talks with the layer 3 protocols while the MAC talks with the layer 1 protocols. It's kind of in between layers 1 and layers 3. Let's talk a little bit about the organizational arrangement of the standards. The IEEE has created many working groups to standardize one type of network technology. Each working group consists of representatives from the industrial and academic communities who meet regularly to discuss approaches and to devise standards. The IEEE allows a working group to remain active provided that the group makes progress in the technology still deemed important. When a working group decides that the technology is outdated, the standard can be disbanded. The services and protocols specified in IEEE 802 map to the lower two layers, network interface and physical layers of the TCP/IP model. The IEEE 802 splits the network interface, called the data link layer in the OSI reference model, into two sublayers named logical link control and media access control, as previously discussed. The IEEE assigns a multi-part category identifier in the form XXX, YYY, ZZZ. XXX denotes the category of the standard, and YYY denotes a subcategory. If a subcategory is large enough, a third level can be added. Example 802 sets standards for layers 1 and 2. The XXX and the 802.15 denotes wireless PAN. Since so many LAN technologies have been invented, we need to have the technologies classified. We can compare their similarities and their differences, such as classifying into a category according to its topology or general shape. A little bit of terminology for you. Network. A network is an arrangement where two or more computers, referred to as nodes, communicate with each other. These nodes actively contribute to the process of communication. Topology is the arrangement of how these nodes will interact and governs data flow between the nodes. So network topology is an arrangement of two or more nodes communicating through a particular medium. The four basic topologies that are used to construct local area networks are bus, ring, mesh, and star.